Let's take another look at our sine and cosine graphs. The standard function below is shown from negative 2 pi to positive 2 pi. I'm showing two cycles of this graph, and yet you can say that the sine function curve will continue infinitely. In other words, I could take another period of this curve and show another period at the end of it. And I can continue to do this pattern over and over again as many times as I like, and I will still have the same sine curve. So the whole purpose here is to show you that the periodic function of sine of x does fit our definition. So let's talk about what happens here. We know this is the kind of function that passes through 0, 0. And in one cycle, the basic cycle that we developed, we came up with values like pi over 2, comma 1, to show that whenever we let x equal pi over 2 and we take the sine of that value, we get y equals 1. At pi, we get 0. Right? So pi 0 is the coordinate point. Pi 0, here we go, is our coordinate point here as we meet the x-axis. That's an x-intercept. We have 3 pi over 2 gives us a value of negative 1, so we go down to as far as negative 1 in our range, and it looks like at 2 pi we're back to 0, and we're going to repeat this cycle over again. You can see pi 0, negative pi 0, negative 2 pi 0, and so on. So what could we say about these things? Well, some observations. Number one, an amplitude. What is the amplitude? Well, an amplitude is actually considered the distance from the center axis to the highest or lowest point along the graph. Another way of looking at amplitude is that we take the largest y minus the smallest y value, subtract, and then divide by 2. Right? So our amplitude in this case is equal to positive 1. This is the basic sine function. It has an amplitude of 1. Period. A period is defined as the distance along the horizontal position here that it takes us to get from one point to its corresponding point in the horizontal direction. Well, negative pi over 2 to 3 pi over 2, for example, has a distance of 2 pi, which happens to be our period of the sine function. The domain is going to be all real numbers, and that is because we can take the sine or cosine of any angle, and we're going to find a value that exists somewhere between negative 1 and positive 1, so this makes our range negative 1 to positive 1. Now, another way of looking at this amplitude right here, if we actually wanted to find the amplitude, is that we could say that the amplitude is equal to the highest part of our range minus the lowest part of our range divided by 2. Right now you want to think about range max minus our range's minimum, divide the whole difference by 2, and that gives us our range. 2 pi, right? 2 pi, we're going to find there are different ways of finding that, but for our basic function sine of x, that's what works. Okay. So now here's the image of our graph of a cosine function shown from negative 2 pi to positive 2 pi, and you'll note that the strong family resemblance to the sine function, the difference being where we start and where we end up. In this particular case, for our cosine function, we note that, for instance, we start, instead of it being 0, 0, we start at 0, 1. We'll note that at pi over 2, we're down to 0. At pi, the y value goes to negative 1. And at 3 pi over 2, we're at 0. And finally, at 2 pi, we're back up to 1. And you'll notice this repeating pattern off to the left at every single one of our point, negative 1 at pi, 0 at negative 3 pi over 2, positive 1 at 2 pi. So what could we say about it? Well, in this particular case, our amplitude is still defined in exactly the same way. We could take our maximum or minimum of our range and divide by 2, or we could just simply see what the difference is from the center axis to our highest or lowest point on the graph is. Our amplitude in this case is equal to 1 in the basic cosine function. The period, the period is in a similar way. The distance it takes us to get from, some people say peak to peak, right? If we looked at this right here, or trough to trough, I suppose, if you're a radioman, you look at some of these values right here, and our period is 2 pi. That's how long it takes for this cycle to repeat. So our period here is 2 pi. What about the domain and range? Well, the domain is going to be all real numbers. Just like sine, we can take the cosine of any real number. And for our range is going to be just like the sine, -1 to +1. So there are still a lot of similarities here between the sine and the cosine graph. The only real difference being where the graph begins and ends. And so this gives us sort of a nice picture. One other quick note right here, you might note that our cosine function is an even function, because for -pi/2 and +pi/2, we might note that we get the same value, y equals 0. Or for pi and -pi, we get y equals -1. Unlike the sine graph, where we get opposites. So sine is an odd function, right? At -pi/2, we get -1, where at +pi/2, we get +1. We'll keep that under your hats, and we'll use that information later.